In order to solve exponent, we always make sure that they have a common base. The base should always be the same. But in this case, it's kind of impossible to turn 5 into 3 or vice versa. So let's get started. Okay, so the only way to solve this problem is to use indices, formulas, and logic. That's the only way that we'll be able to get the value of x. For example, let's start with the law of indices addition. So if we have am plus n, this is the same as am times am times an. So we can use this law first. It will be the first law that we are going to use. So here we are going to apply this law. So this will just be the same as am times am. So we are going to say 5 to the power x times 5 to the power 1. So this will give us 5 to the power x times 5 to the power 1. So we are also going to apply that law here. So this is also the same as 3 to the power x times 3 to the power 1. Okay, so the next step, as I said, we are going to use some logic. The next step is to eliminate this 3 to the power x here. So the only way to do it is to divide all through by 3 to the power x. So if we do that, we are going to have, if we divide it by 3 to the power x, the reason why we are doing it is that we want to bring all the like terms together, 3 to the power x. So we can see that if we do that, we can see that 3 to the power x will cancel up. So we'll be left with 5x. We are trying to bring the like terms together over 3x times 5 to the power 1 equals to 3 to the power 1. As I said, we are trying to bring the like terms together. So the next step is to divide here by 5 to the power 1, or 5 power 1 is the same as 5. So we need to divide. If we divide by 5 to the power 1 and 5 to the power 1, so they will cancel up here. So we'll be left with 5 to the power x over 3 to the power x should be equals to 3 over 5. We also have laws of division of indices that says if you have a n over bn is the same as a over b to the power n. So we can apply that law here. So this will be the same as 5 over 3 to the power x should be equals to 3 over 5. There's always a power. If there's no power, we can put 1. Okay, we are almost there. But if we look here, we have 5 over 3. But here instead, we have 3 over 5. So we can use the inverse law that says that if you have 1 over an is the same as a to the minus n. It means we can invert. So if we change this to a minus, we can change this to a minus and invert it. So it's also going to be the same. Okay, so what do I mean? Let me just invert it first. So if we write this, we are going to have 5 to the power 3 over x should be equals to, instead 5 over 3 we invert and we change the power to minus 1. Changing the power to minus 1, we have not changed anything. As we said with the law, this will be the same. If we want to turn this into positive, we need to write this will be the same as 1 over 5 divided by 3. So this is 1 divided by 5 over 3. If we multiply, it will invert change division to multiplication, 3 over 5. We can see that it's the same thing. This will be 3 over 5. So we just need to invert. So we can now see that here we have 5. The base are all the same. So this implies x is equals to minus 1. Okay, so to check our answer, if we put minus 1 here, if you put minus 1 here, minus 1 plus 1 is 0, minus 1 plus 1 is 0. So this would be the same as 5 to the power 0 equals to 3 to the power 0. 5 to the power 0 is 1, 3 to the power 0 is 1. So 1 is equals to 1. So our answer is correct. Thanks for watching. Please subscribe.